Hi, Savannah and I are here tonight to talk to you a little bit about how we see the colors, how our eyes work a teeny tiny bit. So, when you think about an eye, let's go back a little bit. The other day we talked about reflection, we talked about refraction, we talked about transparent, translucent, opaque. Those were all very important words that we learned the other day when we were outside and the wind was blowing and our hair was going crazy and we had a great time out there. So today we're going to talk a little bit about two major things. I'm trying to squish some stuff in together. So we're going to talk about, first of all, we're going to talk about the eye itself. So let me get a piece of paper. And I'm going to try to do a little bit of drawing, which I'm not very good at, and we all know this. So if you have an eye, so when we think about an eye, we think about an eye that looks kind of, and again, not an artist, kind of like this. And probably Savannah should have been the one to do the drawing here. Okay, so it's not a speech bubble saying, hi, how are you today? Or, boy, you're looking fine. No, it's not a speech bubble. This is going to be an eye. So in your eye, there's a whole bunch of fluid in there called the vitreous fluid, and it sort of like keeps everything in place. It's kind of a cool, sticky-ish white gel. But in the back of your eye, which is kind of cool, we're going to start backwards, is this thing back here, which I will show you in a second. Okay, this back here is called the retina. That's really where all the action is, and that retina is what carries everything through here to your brain. Because this part's the retina, and it's going to be backwards probably to you guys. This part here is called the optic nerve. Optic meaning eyes, and of course your nerve sends you the message to your brain as to what's going on here, because this is really the big piece. But in order for that to happen, there's some pieces at the front. So at the very, very, very front, we have very uneven table, okay? At the very, very, very front, we have this thing right here, like looks like that. And that thing is called the cornea. And if you took that cornea off, it's transparent. So you can actually look through it, which brings that light and color into your eye. Okay, so this right here is your cornea. Then this part right here is your pupil. Now your pupil's cool, and I'm going to draw a pupil kind of over here a little ways just to show you what a pupil kind of looks like. So here is your eye, and then if you, let's say you're a cat, okay, this part of your eye right here would be considered the pupil. So if it's a really, really dark night and a cat is out hunting for food, that pupil is going to be wide open, and it's colored in whatever color the cat's eye is. But in the daytime, like this morning, my cat was out chasing a mouse, and it would be probably like that. So the difference is how much light that pupil is going to let into your eye, okay? So it comes in through the cornea, that hard, it's almost like plastic maybe. It's just a hard piece. I used to dissect eyes all the time. So we used to take cow's eyes and trim them up, and then we dissect them, and the kids loved it. But we don't done that years. But anyway, it comes through here. So here's your light. I'm going to do that with yellow just so you can not see it, probably. Because yellow's doesn't show up too good. Okay, into that cornea, through that pupil, where right here, remember that pupil, okay? Now that pupil, those markers. Okay, that pupil's either going to get bigger or smaller, okay? So we're just going to pretend this is your pupil right here. Now, around your pupil, some of you have brown eyes, some of you have blue eyes, some of you have hazel eyes. Like I have hazel eyes. What color are your eyes, Savannah?
Green.
Green. Green eyes. Very rare. Not as prevalent as, that's about the least amount. Alex, blue?
Red.
Red eyes. Alex is an albino, he thinks. Red from lack of sleep, more hunting. Mine are hazel, so sometimes they're green, sometimes they're brown, okay? So those are what my colors of my eye would be. So right here is where the pupil is. Now, so the color part of your eye is called the iris. Think about the flower, the iris. So you always think the iris, this is your color part. You think the iris is just what makes your eyes color, but no, it's really a muscle. And that muscle will expand to make this bigger or go in to make it smaller like over here. So it's kind of cool how that all works. Okay, so when that cornea and lens, what they do, the cornea is not, notice how I drew it like an arc because it's not straight, it's like an arc. So when it comes in, if we looked at that water the other day in the glass and we had the straw, and I said to you that looks like it's bent because what you're looking at that point, you're looking at bent light, so that it means it's refracted. So that light comes in a refracted way. Now, if I were looking at Alex or I'm looking at Savannah, I see Savannah standing right there. She's straight up. She's like shoulder to shoulder with me. Well, I'm a little bit taller than she is. But here we are, right here. We're both the same. But in my eye, when I first see Savannah, which is very strange, she's upside down. Okay, so then as that goes through the cornea, hits that retina, goes to the optic nerve, whoosh, there, she's on her feet. She's not standing on her head. That would be very strange. So here's a little weird thing. My mother used to have strokes. They were called mini strokes. And one time I went into the house, my brother had called and said, you need to come. And my mom was standing in the middle of the kitchen and she said, oh my God, this house is such a mess. And I'm like, what are you talking about? I mean, the house was as clean as can be. And she said, everything's upside down. Everything's all over. What had happened was when she had that stroke, it affected her optic nerve. So now when we see things like Savannah standing up and down, everything was turned upside down. And that's all she could see. And it took a few days and then her sight came back. But could you imagine walking around with everything upside down? I mean, that had to be horrible for her. So when there's no light, this is very interesting to me. Think about it. Savannah, have you ever gotten up in the night to go to the bathroom or get a drink or something?
Yeah.
Yeah. What color do you see when you get up? What color do you see?
Black.
Black. Because there's no light on. When there is no light, our life is black and white. That's all. As soon as you turn a light on, it gives everything color. But when you're up in the night, it's black and white, maybe a little bit gray. There you go, proof. She's seen it too, not just me. Alex, what do you think? Is it black when you get up?
I live in the dark.
When you're in the woods, Alex, what color are the woods? Do you see greens or do you just see black in the morning at 4 a.m.?
I don't see green anyway. I'm colorblind.
I know, we're going to the colorblind crap. Okay, jeez. You always got to be something special. Okay, so now I have glasses. Savannah has glasses. My husband has glasses. We all have glasses in this house. Why do you have glasses?
Because I can't see far away.
So she can't see far away, but she can see near. Like this is too much for her. It smells pretty bad too, doesn't it? So that's near. So that means that she can see things nearby. So she's nearsighted. I'm also nearsighted. I can see things really good up close. In fact, most of the time I have bifocals because that's supposed to fix both. Bi meaning two, but usually I have to take my glasses off. But anyway, my husband is on the opposite end of the spectrum because he is farsighted. So that means he can see things far away, but up close, he can't see a thing. Okay, so how do we use light? What do we do with all this light? So in our eyes, we have two things. We have rods that lets the light in and cones that gives it a color. So what do you do with it in the first place? So uses of light, they've taken light, and if you want to use a telescope or a microscope, one of the things you have to remember is you have to have light, or else you're not going to see anything. Cameras need light. Now, lasers are pretty cool, and we're not allowed to have lasers in the classroom because they can be dangerous to your eyes. So laser pointers have been used. Do you ever have a teacher use a laser pointer?
Yeah.
Yeah, so they stand back and then point with that.
Mhm.
Okay, I never used one because I figured one of you kids would probably steal it out of my desk. So it's true. Don't you think it's true? Sixth graders, for real, they would. Okay, so a laser's used when you scan anything in the grocery store. A laser's used. I never knew that. Industry uses it. Lasers cut things, metals get cut with lasers, with light. Isn't that cool? Another thing, they align bridges. If you drive across a bridge, you don't want a bridge that's crooked. You'd be all over the place. So they align bridges with a light. A light makes things straight. And then it also, you use them when you put a CD in or a DVD in, it's a laser that shows it. When you want to make a hologram, have you ever seen a hologram?
Yeah.
What do holograms do? They're what? What do they do?
Just like,
How does that work? When you turn them?
when you're trying to like 3D.
Yeah, they're cool. I don't know, I can't really explain them, but holograms, are they a big deal still? I mean, years ago they kind of were. Are they still now?
Saying that postcard that's a hologram.
She did. She sent me a cool postcard that's hologram. I should have brought it downstairs, but it's upstairs. I forgot. Okay, they also use them to perform surgeries. All right, now, all of this has to do with visible light, but everything didn't have visible light. So I just want to show you something very amazing. This is very important, and it's in the notes that I sent you, and it's either on Outlook. I also put your notes in your assignment. So Savannah is going to show us how this works. So slide number 1, dun, 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 is look at these waves, because light travels also in waves. So the very first one, I think I have them in the wrong order. I do. That was my fault, not you. That was me. Okay, the very first one is called radio waves. And look how far apart those radio waves are.
Hold it closer.
Okay, so radio waves, if you want to listen to a radio, which a lot of people don't, but in the cars you do, TVs, cell phones, all use radio waves. Now look how far away those waves are. These are very harmless. They're harmless, right? Harmless to us. These are, you can stand next to the radio, you can do anything you want, you can talk down those cell phones. These are pretty good. These rays are okay. So now she's going to show us our second one, which was really my mistake. Notice we're getting a little bit closer. Okay, this is called a microwave. We use a microwave every time we make popcorn or you warm something up or any of those things. Microwaves are used for that, but they're also used in a lot of communication devices. Microwaves, that's the next one in the electromagnetic spectrum. Okay, then the third one is called infrared. Okay, notice these are still in black and white. Well, a little bit off white. Notice we're getting closer. Those waves are getting closer. You use this in night vision. So people like police officers often will use night vision. Hunters will use night vision. You know, if they're out hunting for like raccoons at night or whatever, they'll use night vision. Okay, so now the cool part, which is kind of cool, kind of scary, this is called visible light. And this on the electromagnetic spectrum, which you have 2 of them I showed you, this is where your visible light comes from. It's really a very small part of this electromagnetic spectrum, electromagnetic waves. Okay, the waves are getting closer together, and this is where we have our light. So now I'm going to, this is called, and when the light comes through, it comes through in these colors because of the amount of waves. So that's when you see that rainbow effect. So you have red, orange, yellow, green, blue, indigo, and violet. So I want to show you something. Hopefully it'll work. I'm going to turn this off, and I'm going to have Alex point the thing up at the ceiling. This is a little handy dandy little toy I bought. Okay, Alex, can you get up so you can show the kids this? Mm-hmm. Okay, this is called a rainbow maker. It's just a light, but it goes through this metal that gives it it bends that light. Where is it? Good, right there. It's pretty good. I wonder how they can see it. I hope they can see it. Okay, if you look real close, you've got those colors again, that red, the orange, the yellow, the green, the blue, the indigo, and the violet. And there's your rainbow. And notice it always works in an arch because of the way the raindrops when that sun hits a raindrop is not like transparent to go through like a glass. It's going to be translucent and it's going to refract that light. And when it does, it bends that light. And then when it bends it, it makes it into this arch. And one thing I learned about today, and I didn't know this, if you ever see a double rainbow, which once in a while you do get to see one, it's two rainbows, but it's flipped. So it actually reflects the other one. It's when the sun goes through a raindrop two ways. So this one would be at the bottom, and then this whole thing, the colors, not the rainbow itself, the colors would flip around. So then the purple would be at the top and the red would be at the bottom, which is kind of cool. I never knew that. So this is a handy dandy little toy. I bought it from Amazon. Just a kind of cool thing. You can put it in your room at night and have a nice, cute little night light. I don't know. I hope you can see that. Okay, so that's your visible light. And thank God for visible light because that gives us color. Okay, so now we have that light. Okay, so we're black to black and white. Now we're at ultraviolet rays. Those are the rays you want to be really careful of. So those people who watched the video today about wearing sunscreen and sun safety, that is because of the ultraviolet rays. That the sun is really good for us. It gives us so much. It is the main source of energy. It gives us everything we need for plants to grow. It helps with photosynthesis, and it's everything. It gives us vitamin D that we seriously need, but we have to be a little bit careful with it because of the ultraviolet rays when they come through that missing ozone. Okay, then and notice that our waves are getting a little bit closer together. Now this one is, the next one is called the X-rays. Those of you who have ever in your life broken a bone, had to go to the hospital or the dentist and get your X-rays taken. Okay, so your X-rays, those are really, really close. And if you've ever noticed when you're in the hospital or in the doctor's office, they'll always put a big heavy thing over you so that they're only getting one part of your body. If you got an X-ray every day, it would be like you getting radiation put into your body and it would kill you. So you have to be very careful with them, and that's why you get them very infrequently. And the only reason is to see if a bone is broken. Okay, and then we get into danger zone. And if you notice, look how close those rays are. Those are called gamma rays. And those are what scientists use. They're very, very, very dangerous because your electromagnetic spectrum is all made radioactive. The whole thing, from the beginning all the way to the end, you're using radiation in the electromagnetic spectrum. So when we looked at all of this stuff together, so on your notes, all of that's there, but just remember you've got parts of your eyes that are very important. They make everything go into just the right way. And then, so know that you have a cornea. Know that there's a pupil and an iris. Know that you have that retina. And in that retina, you have those rods and cones. So my husband is colorblind. His cones and rods are a little screwed up because he doesn't see the same colors we do. And unfortunately, like when you go outside and you see the millions of colors of green right now, he sees probably a very drab green or a brownish color. So, and a cool little fact about that is they usually skip a generation. So none of our children are colorblind, but their children could be colorblind if they ever have any children, which I doubt they're gonna. And then, remember we talked about nearsighted. We have lots of dogs and cats, but not any children. And farsighted. And remember your electromagnetic spectrum and how important that is and why we have that visible light. Savannah, thank you for helping me. Alex, thanks for being the photographer again today. And we hope you all learned something, enjoyed something, and we wish you all a great day. And remember, be kind to one another, and I will see you again on Tuesday. Bye, guys. Have a great weekend. Bye.